Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This is Saadat Ali, SS Physics at DPS and Intercollege Sahiwal. I welcome you to our online channel. I am here to teach you physics. So let's start our today's topic.
Bismillahirrahmanirrahim. Dear students, our today's topic is numerical problems 4.6 to 4.10 from chapter number 4, turning effects of forces. Before starting our today's topic, let's see some previous knowledge. First of all, torque or moment of force. Before starting the topic of torque, we need to learn about what is a rigid body. Dear students, as we read in the previous topic about the rigid body, it is a body that is composed of large number of small particles. A rigid body is the one that is not deformed by force or forces acting upon it. It means that a rigid body will be an object upon which, when force is applied, its shape does not change or it does not get deformed. Axis of rotation. In rotatory motion, we have learnt that axis of rotation is a line around which a body rotates. In rotatory motion, the line around which a body rotates passes through the body itself. Line of action of force. The line along which a force acts is called the line of action of force. Here in this diagram we can see this is the line of action of force, the line along which the force acts. Next, it is moment arm. Moment arm is the perpendicular distance between the axis of rotation and the line of action of force. We can see from this diagram that this is axis of rotation, the line along which the object rotates, and this is the line of action of force. Now, this perpendicular distance that is mentioned by capital L, this is called as the moment arm. Now, what is torque? We have read in the previous section that the turning effect of a force is called torque or moment of force. Dear students, torque is mentioned by this letter called tau, which is equal to F cross L. It means that torque is the product of force and moment arm L. SI unit of torque is Newton meter, that is Nm, which is obtained from this expression. Force has unit Newton and moment arm, that is being distance, its unit is meter. So we obtain the unit of torque as Newton meter. Next, the conditions of equilibrium. Dear students, we know that there are two conditions of equilibrium. First of all, first condition of equilibrium. First condition of equilibrium, a body is said to satisfy first condition for equilibrium if the resultant of all the forces acting on it is zero. Which means that F1 plus F2 plus F3 plus so on plus Fn must be equal to 0. If sum of all the forces acting on the object is equal to 0, then the body is said to satisfy the first condition for equilibrium. And we can explain this situation by this mathematical expression, which is sigma F is equal to 0. Sigma is a letter that is being used for the summation. Now, if we explain the first condition of equilibrium in case of horizontal and vertical forces, then we can explain it as sum of all the forces acting along x-axis, that is F1x plus F2x plus F3x plus so on plus Fnx must be equal to 0. So, sigma Fx is equal to 0. It means that sum of all the forces that are acting along x-axis must be equal to 0. And talking about the vertical forces, F1y plus F2y plus F3y plus so on plus Fny must be equal to 0, which means that sum of all the forces that are acting along vertical axis, it must be equal to 0, and we can represent it as sigma Fy is equal to 0. Sometimes first condition of equilibrium is satisfied about an object, but still the object is not in state of equilibrium. So in that case, there is another condition that needs to be satisfied, which is called as second condition of equilibrium, and it is explained as second condition of equilibrium. A body is said to satisfy second condition of equilibrium if resultant torque acting on it is 0. That is, sigma tau is equal to 0. So dear students, this is the second condition of equilibrium. If an object is to be in state of equilibrium, it must satisfy these two conditions. Now, principle of moments. Dear students, we learned in the previous topic that according to the principle of moments, a body is balanced if the sum of clockwise moments acting on it is equal to sum of anti-clockwise moments acting on it. Mathematically, clockwise moments must be equal to anti-clockwise moments. That is, W1 into OA is equal to W2 into OB, where W1 is the clockwise force and OA is the moment arm of W1, where W2 is the anti-clockwise force and OB is the moment arm of W2. Now students, coming on to our today's topic, that is numerical number 4.6. Coming on to the statement, the steering of a car has radius 16 centimeter, as you can see in this diagram. Find the torque produced by a couple of 50 Newton. We need to find the torque that will be generated by the couple of 50 Newton, as you can see in this diagram. Given data is the couple force, that is F is equal to 50 Newton, and radius of the steering, it is 16 centimeter, as you can see in the diagram. The distance from O to B and the distance from O to A. As we know, centimeter is not the standard unit of the length, so we need to convert centimeter into meter. For that purpose, 16 is being divided by 100, comes out to be 0.16 meter. Now, the perpendicular distance between the forces is 0.16 meter plus 0.16 meter comes out to be 0.32 meter. Dear students, these are the two radii of the steering wheel, which is equal to the diameter of the steering wheel, which comes out to be 0.32 meter. We need to find the torque produced. Solution: torque is equal to force multiplied by perpendicular distance between the forces. That is, putting values in this equation, we get multiplied by 0.32 meter comes out to be torque is equal to 16 Newton meter, and that is the answer of this question. Now, numerical number 4.7. Coming on to the statement, a picture frame is hanging by two vertical strings. The tension in the strings are 3.8 Newton and 4.4 Newton. Find the weight of the picture frame. Given data is tension in the first string is T1 is equal to 3.8 Newton and tension in the second string T2 is equal to 4.4 Newton. We need to find the weight of the picture frame. For that purpose, using the formula, we know that when the picture frame is in equilibrium, then sigma fx and sigma fy must be equal to 0. That is because sum of all the forces acting along x-axis and sum of all the forces acting along y-axis must be equal to 0 for an object to be in equilibrium. Therefore, T minus W is equal to 0, where T is the tension in the strings and W is the weight of the picture frame. As we know that tension is equal to the sum of both the tensions in the two strings, that is T1 plus T2. So above equation becomes T1 plus T2 minus W is equal to 0. T1 plus T2 is equal to W. This W with the negative sign after rearranging comes to this side of equation, and after putting the values of the tensions we can get the value of weight of the picture frame. So putting the value of T1, that is 3.8, plus T2, that is 4.4 Newton, comes out to be W is equal to 8.2 Newton, which is the answer of this question, and this is the weight of the picture frame. Coming on to our next question, that is numerical number 4.8. Statement: two blocks of masses 5 kg and 3 kg are suspended by the two strings as shown in figure. Find the tension in each string. Dear students, as you can see in this diagram, there are two blocks of masses 3 kg and 5 kg. They are hanging vertically with this string. We can see that this string is supporting both of these objects, 5 kg and 3 kg, while this string is supporting only this object, that is 3 kg object. So given data is M1 is equal to 5 kg, M2 is equal to 3 kg, and we need to find the tension in the upper string T1 and the tension in the lower string, that is T2. Solution: tension in the string A is due to both masses, as I have told you from the diagram. So we can find the tension in the first string T1 is equal to W1 plus W2, that is weight of the first object plus weight of the second object. We know that the expression for weight is W is equal to mg, so the weight of the first object comes out to be m1g and weight of the second object comes out to be m2g. We can take g common from this equation and we are left with T1 is equal to m1 plus m2 into g. Putting the values of m1 and m2 in this equation, we get T1 is equal to 5 plus 3 multiplied by 10, that is the value of gravitational acceleration. We get T1 is equal to 8 multiplied by 10, comes out to be T1 is equal to 80 Newton. So dear students, this is the value of the tension in the first string. Now we need to find the tension in the string B, that is the second string, due to the second mass only. Now T2 is equal to W2. This is because the tension in the second string is due to only the second mass, that is of 3 kg. So T2 is equal to M2 into G, which is the value of weight of the second object. Putting the values in this equation, we get T2 is equal to 3 multiplied by 10. 3 is the value of second mass and 10 is the value of gravitational acceleration. And we get T2 is equal to 30 Newton. And this is the answer of this question. Now moving on to our next numerical, that is numerical 4.9. A nut has been tightened by a force of 200 Newton using 10 centimeter long spanner. What length of a spanner is required to loosen the same nut with 150 Newton force? Given data is the force, that is F1, is equal to 200 Newton and the length of the spanner, that is 10 centimeter. We need to convert centimeter into meter, so by dividing 10 by 100 gives us 0.1 meter. Now the second force, that is 150 Newton, F2 is equal to 150 Newton. To find the length of the spanner, we know that in this situation there are two different torques. One is torque 1, which is created by the force 1 and the length of the spanner that is given in the statement, and there is another torque, that is T2, which is created by the second force, that is 150 Newton, and the moment arm L2 that we need to find. Now dear students, by cross multiplication this equation becomes L2 is equal to F1 into L1, and F2 being divided on the other side of equation, we get L2 is equal to F1 into L1 divided by F2. Putting the values of F1, L1 and F2 in this equation, we get 200 multiplied by 0.1 divided by 150, that is the second force. We get L2 is equal to 0.133 meter. If we need to convert this value from meter to centimeter, we shall multiply this term by 100 and we get the value of our spanner in centimeter as L2 is equal to 0.133 multiplied by 100 centimeter gives us 13.3 centimeter, which is the length of the spanner which is required to open the same nut with the force of 150 Newton. And this is the answer of this question. Now students, coming on to our last numerical, the statement is a block of mass 10 kg is suspended at a distance of 20 cm from the center of a uniform bar 1 meter long. Dear students, you need to understand this statement according to this diagram very carefully if you need to solve this question. As we have read the statement, this is a block of mass 10 kg that is suspended 20 cm from the center of a uniform bar that has length 1 meter. So its center must be equal to 50 centimeter and the distance from O to A is 20 centimeter. What force is required to balance it at its center of gravity, that is this point O, by applying the force at the other end of the bar? So given data is mass of the block 10 kg, length of the bar L is equal to 1 meter, moment arm of W2, this force that is mentioned by OA here in this diagram, OA, it is 20 centimeter, that is mentioned here. Now converting this centimeter into meter, we divide 20 by 100, comes out to be 0.2 meter. Moment arm of W1, which is mentioned by OB on the diagram, that is equal to 50 centimeter. As I have told you, because this is the distance from center of gravity to the end of the bar, which is from 0 to 50 centimeter. So we need to convert this 50 centimeter into meter. Dividing 50 by 100, we get 0.5 meter. What is the force required to balance the bar? That is F is equal to W is to be determined. Dear students, by applying principle of moments, we know that the mathematical form of principle of moments is the sum of clockwise moments must be equal to the sum of anti-clockwise moments. Clockwise moment W2 into OA is equal to anti-clockwise moments W1 into OB. We need to find W1, which is mentioned as W here in this statement. So by cross multiplication, this equation becomes W1 is equal to W2 into OA divided by OB. We get M into G multiplied by OA divided by OB. Students, this mg is the value of this weight, that is W2. M is the mass of the object and g is the gravitational acceleration. So putting the values in this equation, we get 10 multiplied by 10 multiplied by 0.2, that is the value of OA, divided by 0.5, that is the value of OB. We are left with the answer, that is 40 Newton. Thus, a force of 40 Newton at the other end of the bar is required to balance the bar. Now students, let's solve an assignment for the practice of our today's lesson. There are three very simple numericals that are quite identical to our today's numericals. First of all, a block of weight 10 Newton is hanging through a cord. Find the tension in the string. Use the formula tension in the string, that is T is equal to W, and you can solve this question very easily. Now the second numerical, that is quite identical to numerical number 4.6. The steering of a car has radius 8 cm. Find the torque produced by a couple of 70 Newton. Third question, a nut has been tightened by a force of 200 Newton by a 20 cm long spanner. What length of a spanner is required to loosen the same nut with 100 Newton force? You can see this numerical is quite identical to numerical 4.9, and you can solve these assignment questions very easily if you understand our today's lesson. That's all for today. Thank you very much.